Welcome. This is a demonstration of the LMKR GVERSE inversion powered by FracGeo Technologies. GVERSE inversion is a colored inversion technique which provides a rapid yet robust solution to derive relative or absolute impedance volumes, a proxy for rock hardness. The advantages of this technique are that it captures a high-resolution image of the reservoir inherited from the seismic dataset. This high resolution helps to spatially identify the best locations to drill, and vertically enables the operator to identify optimal landing zones. Along a planned wellbore, optimal completion strategies can be developed based on the inversion volume. The input data for this technique are acoustic impedance logs derived from sonic and density logs, and also post-stack seismic volumes. Using only this data, we can construct an operator to convert the seismic amplitude to an equivalent acoustic impedance volume. Now that we have an idea of what this tool seeks to accomplish, we will work through a short demonstration of the GVERSE inversion tool. We begin in the LMKR Size Vision interface. To effectively use the GVERSE inversion, we have to make sure that all horizon interpretation and seismic to well ties have been adequately QC'd in Size Vision. The seismic volume must be zero phase and tied with a zero phase wavelet. To launch the tool, first we click on the map view and make sure that the appropriate seismic cube has been activated. Then we click on Tools and click on the GVERSE inversion. This is the Inversion Data Selector interface. On the left side are a summary of the seismic cube we want to import into the GVERSE inversion. It shows basic information about the volume, such as the number of inlines and crosslines, and additional information. The output parameters give us the ability to delimit the seismic volume we want to import, in case we are interested in a certain reservoir or limited part of the seismic volume. We also make sure that the resampling tool is activated, which is necessary to get a high-resolution image. The lower half of the interface shows the wells within the field with sonic and density logs. At least one well log must be selected for the algorithm. If no logs are selected, an error window will remind us. In this example, we will use all of the logs and then launch the tool. This progress window shows the data being exported to the GVERSE inversion. Now let's do an inversion. Let's start by setting the time range for extracting an amplitude spectrum. Careful, this range must be covered by all of the logs to be used. Notice that as I click on individual logs, the algorithm goes to the wellbore location to extract the amplitude spectrum. Each of these are plotted in the window on the left. On the right, we see the mean of these spectrums. We can smooth this mean amplitude spectrum. In this case, we will stick with the default. Note that we are unable to select the impedance logs. This is because specific tools unrelated to the current task are grayed out. These tools will be active as we move to subsequent tabs in the workflow. If we click on the Wells tab, we can now choose the equivalent impedance logs to use. In this case, we can use an auto-calculated impedance log or a previously calculated impedance log. This is useful if we intend to invert for an angle gather. In this case, we would have to calculate the equivalent extended elastic impedance log. Now let's do a little bit of visualization. Let's select an equivalent well location. we'll use this magnifying tool to focus on the well. And let's change the color scale a bit to enhance the visualization of the volume. We can now see that the impedance in the seismic section respects the impedance from the well logs. The next step is to design the operator. First, we select an operator length, which we will set to 150. Here we have the seismic amplitude spectrum in red, the well log spectrum in blue, and the filter spectrum in green. We will apply the operator spectrum on the seismic amplitude to get the equivalent log impedance. Once we are satisfied with the operator, we will save, and we can now run the inversion over the entire volume. We can select the volume we wish to export back to SizeVision. In this case, we will export the entire volume. The volumes are now being exported back to SizeVision. We will add the volume to the interpretation. And since we added the new volume to the interpretation, we can visualize the result by right-clicking and select Dataset Version, and select our inversion results. We will select a new color scale to analyze the volume. The result is a good correlation between the impedance log and the relative impedance volume. Thank you.